Okay. Um, are you
Yeah,
sharing?
I am sharing my screen. I
Okay.
hope it's seen by everyone at this moment, right?
Okay. That's good. I was thinking.
The
Okay.
screen is shared by
Okay.
everyone, so I think that would work. Um, hi guys, how are you? I hope you're all well. Thank you so much for bearing with us. Again, my apologies for having an issue. In case of anything, kindly let us know through the chat. Any questions, we'll be able to attend. Again, sorry, I'll just reiterate, as this is our second week, we decided that these classes are going to be short, 30 minutes each, to ensure that we have enough time to intake as much information as possible. Now, without further ado, we can just get into it. So, I'm the speaker. I'm still the same person. My name is Dickens. I go by the tag name Decode or Alias. And so we'll start by security mindset surrounding Cairo and Starknet. So Cairo is a highly safe language and it's highly inspired by Rust, as we know, right? Initially, if you had early interacted with Starknet and Cairo when you were doing like something like Cairo 0, because it was not inspired by Rust or it was not Rust based, there are a lot of things that could go wrong then. Because remember, we didn't even have when you're writing a function, a view function can modify state. It was just like a write function. So there was not a lot of security parameters per se in regards to the way Cairo was written previously, prior to Cairo 1. But because it's Cairo 1, it's highly Rust based, there are a lot of security safeguards within the language itself. So this ensures that we do not, it's highly unlikely rather that the language itself introduces some security challenges per se. Because now, if you've written Cairo, which I'm assuming you have, you'll understand that you have to declare through your interface if something can modify the state of your contracts or not. If not, if it is not declared, then it won't be allowed to modify the state. You understand how overflows are impossible because we are using when you're using unit versions right now instead of felt elements in Cairo. So because it's highly Rust inspired, then there are a lot of safeguards that have been done in Cairo 2 as we're speaking right now. So security issues on Starknet will highly arise from smart contracts flow, not much so from the language itself. And this is why if you had attended like last week when we were having like security issues, you really get that there are a lot of logical issues within Cairo itself and not necessarily language specific issues that you'd get. The same thing I think I can speak about the same way about something like Ethereum. It's rare we get Ethereum specific issues that are uh, so for Starknet, because we are the language written in Cairo, I'm not saying it's now there's nothing fault proof in this world because human beings are imperfect, but highly a lot of things will come from logic issues. Now, there's common things that we wish to understand or we wish to have our thoughts on as we continue. We need to understand one thing. So transactions are atomic. So what does that mean? There are two things. They either succeed or fail without making any changes. As we talked earlier this week on Monday about the need of Starknet, we understood that a state machine is that it is a state machine. Its work is to change the state from 1 to 0, right? So the state changes either succeed or fail. So that is the most important thing. So when we have that thinking, the transaction in smart contracts are atomic, it helps us. It helps us because we are thinking of smart contracts as state machines. So they have initial states which are defined, and then external functions generally have the ability of changing these states, right? So for example, if you have a public main function, the main function has the ability to change the state of the smart contract. So that is very, very, very important. The beauty of Cairo right now is you can use some things like assert and panic to ensure that you validate conditions before performing actions, right? You need to maybe ensure that the caller is an allowed caller, as you will see. So having this mindset is important because it now helps you in analyzing security related changes, right? We can now think from a security point of view on what could go wrong because we have an understanding that one transactions are atomic, meaning that they either fail or succeed, and therefore we're just looking at state changes. So as you are doing your security, understanding security parameters, you just need to know that a security issues is where you force a smart contract into a state that is not desired, right? Because you understand it's a state machine. So it is just pushing this smart contract into a state that it was not intended or that it was not desired. The state can include user B having more balance than they could, user A having more access than they should. It's just pushing the contract into a state that is not desirable, right? So I hope that is understood. We can move into now common vulnerabilities. Again, these are just common vulnerabilities. We'll just go through them. And then from next week is when we'll get really technical and according to the curriculum, we will have some practical things that we will now work on through using certain tools such as Foundry. So this week was just an introductory bit. Now, I'll speak about access control. Again, our mindset at this point is that we know that security issues necessarily would not originate from the language itself, but from the design of the language. Therefore, we are looking at the implementation of this language and what impact it can have. So I'm 100% sure most of you, if not all, understand the concept of access control, right? It's an authorized user is not supposed to perform certain actions within the system, right? So, for example, we have this snippet of code where there is a mint tokens function. Now, I am sure, as you can see, there's no input sanitization, right? We do not validate the input one, and also we do not validate the call. So what does that mean? It means that anyone can call the mint tokens function and increase the token total supply. Again, is this the intended logic of the contract? No, not necessarily. When we go back here, when we talk about the mindset, we can use the two macros, such as assert specifically in this case, to ensure that we need to assert that the caller is an authorized entity. So access control is something that we'll see in code. That you'll see. It doesn't matter the language itself, but still in Cairo you have access control issue. So you need to ensure that only authorized users are able to access or are able to perform certain state changing operations within the language, something like a public ban. Earlier days of Solidity, we had most issues of access control back in like 2020. There was a lot of issues of access control. So those public bans, public means function, a user can just change your tokens without your authority. There's just a lot of access control issues. So right now, OpenZeppelin, I know they have an access control template which you can use that is role based, where specific roles are given to specific users or entities who, when they interact with the system, they are authorized to perform these functions. Now, the second they're just there. You will 100% every day find it. So reentrancy. Reentrancy is an issue that has really faced smart contracts from all languages, to be honest, because as you understand what are reentrancy bugs, these are where there's an external call before updating an internal state. So because we understand, again, going back to this mindset. So this is what we understand. We understand that transactions are state changing. So when an action is supposed to change the state of the contract, but now the flow of the call is given into a secondary entry. For example, in this function here, if when we're having this call back to the sender, if the sender is a smart contract that implements an on-receive SWORD function, and in this function they do something as long as this whitelist true, then you have an issue, right? They can re-enter. So common security measure towards re-entrance is checks effects and interaction pattern, where we ensure that external calls are the last thing and changing operations happens before updating internal state of our smart contract. So again, in Cairo you will get reentrancy, but we won't get reentrancy in the form of solidity, something like low level call of ether, where when you have a low level call when you're transferring something like ETH, we don't have those types of reentrancy back. But just understand the concept of reentrancy, where the call is transferred into an external entity, and then state changes happens thereafter. Still, it introduces issues that do with reentrancy. So I think that is also something that we can consider. Another thing that we should know of is felt elements, right? We have a pitfall of felt elements, because we understand that Starknet does not know any integer form. It only has a single data type called a felt element. Though with Cairo 2 these days we have UINs, but they are transformed into felt elements at the end of the day. It's highly advised right now that you don't use felt elements in certain things, such as balances in amounts computation, right? Because they are prone to overflows. They're still prone, because we understand a felt element is a large prime number, slightly lower than the range of 2 power 252, and they can directly cause overflows. So those are not present. So when you're doing like accounting computations, if it's an ERC20, anything that just does with anything that has something to do with accounting, it is proper that you just use UNIT 256 or any flavor of it, either in 1632, 64, etc. But felt elements still have the issue of overflows. Yeah, so and also because felt element is defined, rather it is confined into this range, it means that when you are writing, okay, by the way, everything in Cairo and written, it is transformed into this felt element. So even if you write a string, Cairo technically Starknet does not understand anything called a string. So when you're writing a felt element, so you should not really write large strings in terms of maybe you want to catch an error through your panic statements, because large strings would not fit into this. So everything has to fit into this felt 252. Yeah, so those are issues. This one is just renowned. Private data on-chain. So we understand that all on-chain data is publicly accessible, right? So for example, here you cannot store a password in your contract or anything that you don't want the entire world to see, because when you understand the SN KICAC, we understand through the storage the layout of Cairo, right? Everything is hashed into a specific KICAC version, and you can literally write a script to read the stored variable. You literally can. So don't store anything private on chain. Just don't do that. Yeah. So just understand that everything that is on chain is accessible. So that is also something that you can consider. So other common vulnerabilities that I think it should be at the back of your head is something like denial of service. When you have like an extensively long loop, that can happen. Or if, let's say, you don't want, for example, panic statements, right? So if you don't want your contract to reach a certain state, right? Let's say you don't want the balance to increase into a certain parameter, but manipulation of that balance can easily be attained, right? So you just need to ensure that you need to check all denial of service states, right? And this takes caution into our usage of assert statements and panics. And as much as they are useful and validating, do not overuse them in your code, because when you overuse panics, it means that it should not be easier for an attacker to trigger these panic statements, right? Or to deny others. So I think you can consider something like that. Flash loan attacks, of course. Basically, all attacks that are present in Solidity, most of them are still present in Starknet. And again, they are not language specific. They're mainly logical issues. So flash loan attacks, they're still prevalent. Oracle manipulation, right? So when let's say you, for example, something like flash loan attack, if you're reading the spot price of anything through the state of your, like you're using your contract balances, then you still have the same issues. For Oracle manipulation, yes, still possible. But randomness, again, this talks to the implementation of your logic in your code. It does not really necessarily talk about language-specific issues, right? Yeah, so up to there, I've really gone fast because I understood that it was our fault that we had a network, like a connection issue, so I didn't want to keep you here waiting. So like just ran through issues without checking the chat. So does anyone up to this moment have an issue or a comment or anything that is not clear that I can repeat? Yes, Kazim.
Yeah. We were talking about the reentrancy attack, and working with Starknet contract carriers, I noticed there is no fallback function, and aside from the illustration you did, I noticed there is no fallback function and callback function on receive for Starknet contracts. Does that mean the only time we can change a state, the only time we can change a state before sending an external call, or before, for an instance now, let's say we are using this normal ERC20 standard, and you transferred before changing a state? Does that mean there's going to be a possible reentrancy attack, since there is no callback function, unlike how we have it in Solidity, that when you send money or you try to do any transaction with a contract, a callback function is triggered, which is a fallback function or receive function?
Yeah, thank you so much for your question. It's a good observation. All tokens in Starknet, they are ERC20 tokens. Even Stark itself, it's an ERC20. Everything in Starknet is an ERC20 token. So for Solidity, it was important because we know ETH is not an ERC20. That's why for you to interact with ETH, it has to be wrapped. We interact with wrapped ETH. So for contracts to receive ETH, they had to declare a receive function, right? So for Starknet, we just need to understand the ethos, rather the logic where reentrancy issues comes from. When you just need to understand that reentrancy is where a call is transferred to an external party and this external party has the ability to change the state, like they can take over the entire call. So, for example here, in this function, in this callback function, right? Because we have a state update here, it means that we are basically transferring the call to an external user here. So this external user can implement logic to do anything to re-enter, because that is the logic of re-entrancy. The call has not yet finished, and then we re-enter call. So because there's an external call to a sender, the sender can re-enter code without the entire contract call finishing from here. So yes, re-entrancy in Starknet, the logic or the ethos of re-entrancy will still persist, but not necessarily in the same way that is in Solidity. Because again, you don't have receive, you don't have fallback functions, and everything basically is an ERC20, including stack tokens that are used to pay gas, right? So understanding that, you should also know that in Solidity, the only way you could get re-entrancy function was not necessarily through a receive, as that was one of the ways. But even in Solidity, if you have your logic and then you transfer the call to another function, let's say you call a function of the sender without updating the state at the end of, before it, then re-entrancy will still persist. So yeah, I'm just saying, like, the way in Solidity is, it won't really be there, but the entire logic of re-entrancy still persists in Starknet. Maybe not the exact traditional way that you're used to, but if you have your contract call, and then this contract call is transferred to an external party, and then and then there are set changes thereafter, then we still have re-entrancy issues. I hope I've answered well, Kazim.
Yeah, thank you so much. Also, sorry, please. You mentioned about DOS the other time, the other vulnerability.
Yeah, denial of service.
Denial of service. I've been kind of trying to. I just I just got to. Like, I wanted to ask, like, at what situation can we have a DOS attack? Then I just realized. Thank you so much.
No, thank you. Yeah. Any other person? Any other question? Okay, so if there are no other questions, so this week we've basically been talking about an introductory concepts, right? We're just introducing ourselves into Starknet, or Starknet, and maybe basic security issues that you can look at. So starting from next week, we'll now be interacting. We'll now write tests. We will now debug some contracts. We might even look at. It will be more practical. That is what I'm saying. We'll go deeper next week, and we will be using Starknet Foundry. So if you haven't installed it, interacted with it, probably you can, so that it would be easier by the time we are having the class. We will. Yeah. So we'll set up the environment, interact with a few contracts here and there, test a few things, write tests to catch a few bugs, or we can even write examples for some of the issues that we mentioned over here, right? So yeah, it would be very interesting. So next week we'll go deeper into how you can test your contracts, how you can identify bugs, how you can test issues through unit testing, etc., and how you can use Starknet Foundry in this case. So that's it from me. Again, sorry so much. I joined probably 8-10 minutes late because of connection issues, but we promise it won't happen again. Is there any other question? If none, I'll hand it over back to David, and thank you so much, guys, for attending the class.
Okay, thank you, Mr. Dixon. Thank you. Well done, guys. So I think that will be all for now. From next week, we also believe you get to have some assignments and some assignments for continuous learning. So that will be all for now. Please, any question you could talk, you could have the communication on the Discord channel. I hope everybody has joined the Discord channel, so you could all have put in your questions, comments, or any other further communications. Thank you, and see you guys next week.
Bye bye. Good night, guys.